and thank you for joining our HP webinar this morning. So we have John McDonough here from HP who will be going through the webinar with you.
Morning everybody, and thank you for taking the time out to get an understanding of what HP Virtualization Performance Viewer, or VPV, is. What I'd like to do is go through a relatively short presentation and finish off with a demonstration of the product. So hopefully it'll give you a flavor of what it can do in your environment. So just I wanted to set the scene in terms of why VPV, or why HP would have such a tool. I think those long enough in the industry have seen, I suppose, an evolution happening in terms of the environments we have to manage. So we started off with our compute power locked away in a room somewhere, and we all connected in via terminals. We moved on to the area of client-server computing, where compute power was distributed out. Then we saw the introduction of web-based services where we could access it from anywhere, to a point where we have multi-tiered applications, and obviously then along came the game changer, or virtualization. So that virtualization infrastructure has brought about the area of cloud computing, so hosting cloud computing, whether that's private, public, or hybrid. So our applications now possibly could be living in a mixture of those environments. So whether that's some parts of it hosted out in the cloud, some parts of it in-house. And that virtualization layer has created a new complexity in terms of managing that. How can we get a view in terms of to understand the performance and the availability of our assets and applications? It's getting that visibility or line of sight into where the performance and availability problems may occur. So some of the challenges of virtualization management in that new layer that we've introduced. So in terms of availability, now that our converged systems in terms of storage, network, and systems are all in one box, so to speak, how can we see if our infrastructure is available? How can we see the, whether our applications are up and running to the point of the parts of the that are hosted in the virtualization layer? The business impact of that obviously is the infrastructure is down. We've got users standing by waiting for systems to come back up. Users or customers may be moving elsewhere because they can't get access to the system. So there are some of the business impacts that we see as a result of that. And because it's become relatively easy to move around our guest VMs or our workloads around our different clusters and resource pools, whether that be manually or through the likes of vMotion, it's difficult to keep an eye in terms of where those resources or workloads are from time to time. So is it a case of not having visibility of where a particular guest or VM or workload is now positioned? It takes longer to maybe see where the problem is, and therefore longer to fix the problem. So our business has experienced maybe possibly longer downtime and subsequent revenue loss, etc. So within our physical infrastructure, we've got a finite set of resources, and our guests or our workloads or VMs are all competing for those limited resources. So being able to get a view in terms of what, how our systems or how our resources are being used, are we sweating them, or are we underutilizing them, that type of thing. So the end effect of that will be, well, maybe it won't be an outage as such, but it'll be an end user experience, an application response time. So it might have slowed down because we haven't given enough resources to that particular infrastructure, or and obviously the placement and the optimization. So obviously when somebody comes and looks for, you know, a system to host their application on, the human nature will will tend to say, well, get as much resources as possible for the box. It's better to have it than to look for it. So you might tend to be over-resourced in terms of you know, the CPU, the memory, the disk, etc. So having that mechanism of optimizing how we allocate those resources, those finite resources out amongst the different systems that our virtualization layer is hosting is key. And the effect of that is we may be more frequent procurement of additional hosting services, so slow down the purchase of those additional finite resources that are sitting in our physical elements of our virtualization there. I just wanted to talk about then the whole, what we call the 6 dimensions of virtualization and cloud management. So in the center there, the blue box, we've got our physical infrastructure layer with all the finite resources that we've allocated to that physical infrastructure. Sitting on top of that then is the hypervisor layer that goes to produce and or divide up those resources to the platform there, our operating system that's sitting on top of that. And that platform or operating system then goes to feed the application there, where we have our applications and web infrastructure, database, etc. So when it comes to monitoring that infrastructure, well, you know, we have our systems management, traditional systems management monitoring that, the likes of HP Operations Manager, all the way up into the application layer. And then from an end user's perspective, how are our end users experiencing those applications? Are they slowing down? Are they, you know, are they okay? How can we benchmark them? So the likes of HP's business process monitor and real user monitoring those applications from an end user's perspective. So if we look at the circle of how we manage that, or how we I suppose triage and get alerted to the fact that we have problems in our environment. First thing is to discover. If we don't know what we have, we can't manage it. So what have we got in our environment? What systems, what OSs, how do they all link together to form our applications? Then we have the measure and detect. So what is causing a problem? Do we have any issues in terms of our infrastructure slowing down, outages, etc.? We've benchmarked against certain thresholds, and if we go outside of those thresholds, we want to know about it. We're alerted to the fact that we may have a problem with our infrastructure by the likes of an event or an email, etc. And as we identify where within our infrastructure, is it the virtualization layer, is it the DB layer, is it the OS layer, etc., where that problem is it coming from, that particular subject matter expert has to go off and triage and find out what the problem is. So this is where Virtual Performance Viewer, or VPV, sits. It's a diagnosis and triage tool for our virtualization layer. And it's also given us the optimization, or the ability to optimize how we allocate those resources out so that we reduce the tendency for performance and degradation of service issues. And if you complete that circle then in terms of automating the mundane tasks, automatic remediation of problems, etc., that you know, there are tool sets out there for that. But VPV sits in this diagnosis and triage and optimization layer. So the benefits of HP's virtualization and cloud solution, or VPV. Well, it's there to manage virtualized and cloud environments. It's vendor neutral. It supports multiple hypervisors. So in terms of no vendor lock-in to a particular platform. So hypervisors and cloud systems as well. So from ensuring the performance and availability, it's there as a tool set to help us troubleshoot, get to the root cause of the problem as quickly as possible, and therefore reduce the amount of time that our application or our service is unavailable or performing badly. And it's there to complement what we've already got in terms of our traditional monitoring solutions as well. So as I said, it's we've, you know, the traditional monitoring solutions will have identified possibly where the problem is. If it's down to the virtualization layer, well then that's where VPV comes in terms of triaging and troubleshooting that. So, cost of ownership, fast time to value in terms of how long it takes to get the system up and running and how long it takes to get valuable data from the information or valuable information from the data it's gathering. And you'll see hopefully in the demonstration later on in terms of its ease of use, how quickly one can use it to find bottlenecks or problems within our virtualization there. And of course, in terms of scale, you may be starting off in a small way in terms of cloud and virtualization, but that's obviously going to grow in time. So it's going to scale to the level of enterprise management systems for virtual and cloud environments. And it's there then to help you optimize those resources within that cloud or virtualized environment. So in terms of investment protection for the future, well, it integrates with HP's BSM and cloud solutions already. So if you invested in those solutions, then there's a out-of-the-box integration with them. And as more architectures and platforms need to be supported, that will be done because we're not locked into any specific vendor. So what is Virtualization Performance Viewer? Well, first and foremost, it's a practitioner tool for the virtualization or cloud subject matter expert or administrator. So it's there to help them triage, troubleshoot performance issues, and obviously optimize how we allocate those resources or those limited resources amongst the different guests and VMs, etc. It uses the concept of a tree map, so allows us to visually identify problematic elements fairly quickly and intuitively. I'll talk a little bit about the whole area, the meaning of that tree map in a subsequent slide. Now that we've identified maybe a hotspot or some issues within our virtualization environment, it gives us the ability then to use the performance workbench, so a deeper dive into the performance metrics that we're collecting on a continuous basis from within the hypervisor or cloud layer. And no management tool is complete without a series of reports. So there's out-of-the-box reports in terms of trends, history, etc. It also gives us the ability to optimize how best we allocate those resources. So how do we right-size our environment? How do we reclaim maybe over-resourced elements of our environment so that we can reuse those elsewhere, again to slow down the purchase of additional components that we need to increase our resources with. And one of the unique areas that HP see in terms of VPV is the ability to get down to the guest level in terms of performance and triage. So a lot of the vendors' tools look at the hypervisor layer, but we're going that little bit deeper in terms of being able to give you a visibility and debug capabilities down into the guest OS level itself. So the tree map, what is it? It's there to give us a quick visualization of what that problem might be. So is there an interesting pattern? Can we establish that it's, it's something of the underlying, whether that be the cluster, the resource pools, etc. So identifying a pattern so that we can get to the root cause quickly. And it's the boxes represent a two-dimensional view. So they could be, for example, the amount of available resources allocated, whether that be memory, storage, CPU, and the color denotes then the degree of utilization of that. So the classic traffic light view in terms of, well, okay, it's something is struggling in terms of high CPU usage, whereas some other guests there are sitting with relatively okay. So it's allowing us to be able to quickly see where problems are arising. So obviously the more you increase the usage of virtualization and cloud technology, the more difficult it becomes to see performance issues. So having that quick way to visually see where the problem is and what the problem is very good. Talked about earlier on about the performance workbench. So VPV is gathering and storing information on a continuous basis from that hypervisor layer and cloud layer to be able to look back in time and say, okay, well, what happened maybe an hour ago or a day ago in terms of those particular metrics. So disk, memory, CPU, etc. All the standard metrics that you would expect to be gathering from that hypervisor or cloud layer. And it gives you that explorer view of environment, being able to navigate, as I said, a time range, access problems that have occurred in the past, so that look back in time, and compare systems. Maybe you want to compare one guest VM with another guest VM in terms of its performance, again with a view to triage and what problems are. And as I mentioned, out-of-the-box reports in terms of the likes of inventory of our virtualized environment, the trends of usage, different metrics in terms of being able to graph those and report on those over a period of time. The likes of what guests are the biggest users of my resources, being able to maybe to feed that back to the owners of those guests and say, to give them a decision-making process in terms of how best to optimize their environment. And again, all available for export in different formats. As part of VPV, there's an element of optimization or capacity management. So what is my current capacity? How am I using that capacity, and how have I allocated it to my guests? Have I a situation where I've oversized guests based on the past gathering of data in terms of how they perform? So if we've allocated too much CPU or too much memory to a box that doesn't appear to be using it over a period of time, can I rescue that back and allocate it to something else? So giving us that ability. And letting the tool optimize or suggest optimization strategies. So if, for example, it's looked back over time and said that particular box hasn't been sweating, so therefore I can reuse some compute power from that and allocate them elsewhere. So it comes back in terms of suggestions as to how you could allocate those resources. And based on historical performance, when am I likely to run out of compute power within our environment? So looking at trending in terms of if I continue the performance that I'm getting from my system now into the future, at what stage will I need to go out and purchase additional resources or increase the capacity, etc. So giving us that visibility into that aspect. Mentioned earlier on the whole area of guest drill down. So we can detect overloads, and a lot of tools will do that in terms of at the hypervisor layer, giving us that visibility of where the resources are being used, how much those resources are being sweated, etc. But it could be a situation where you need to get a deeper insight into the actual guest or the VM itself. Now, the traditional way would be, I suppose, go out into other tools or remote login, check some metrics, see what's happening on the box. But from within the same tool set, the ability to access that workload or remotely gather that information from that guest VM. But a small piece of instrumentation loaded onto that guest VM, we can gather a huge amount of data in terms of what's happening on the box. The idea there being we've identified maybe a troubleshoot or a noisy VM that's impacting other VMs within the environment. What on that VM is causing the problem? So being able to get a little bit deeper in terms of what's causing the problem in the first place. And that can go down to a 1-second level analysis, so really up to speed or up, real-time view of what's happening in our environment. I talked earlier about not being locked into one particular vendor in terms of a management tool. So we support obviously the popular ones in terms of VMware, Hyper-V, Xen, KVM, and then cloud services as well. So it's there for cross-platform management. And if you've already invested in some of HP's other tools in terms of cloud service automation, there's a very tight integration between the two. So as users self-service allocate systems for their use, they can also then see in terms of how those VMs that they've allocated are performing. Is it a case that I need to increase resources on or decrease resources on it, etc. And integration into our monitoring, our traditional monitoring systems and the end user management experience systems as well. So tight integration in that as well. So I just wanted to talk briefly about the structure and the different versions or editions you can get. So there's a community license which is free to download and free to use. Obviously there will be restrictions in terms of what it can do, so it's limited in terms of 25 instances. So those instances would be considered to be the guest VMs. Obviously shorter data retention and limited functionalities you can see there in the graphic. But it's there to give you a flavor of what you can use the product for, show how quickly you can get it up and running, how quickly you can start to gather information and use that information to make decisions. There are two licensable editions, so the Express and the Premium. Obviously scale in terms of the number of instances is well catered for there, and the data retention much longer. So the difference between the two obviously is, the more advanced features is available within the Premium license. There's also an evaluation license, a 60-day evaluation license that gives you all functionality and obviously free to download and try for 60 days. How the product is licensed is based on the number of OS instances it's managing. So an OS instance is, if you have a hypervisor with 49 guest VMs on it, that's 50 OS instances you need to license. And it comes in packs of 50 node count. And there's also a term license if you want to take the Express or the Premium license for a term period as well. Time to value I put down as one of the key benefits of the VPV solution. We had a survey done by TechValidate, so an independent survey, and asked people who have downloaded and licensed VPV, how long did it take them to get up and running and get meaningful information from it. So you can see the majority happened within less than 30 minutes. So I think that's a testament to how quick one can get using the product and the time to value that you can get from it as well. And there was, as part of that survey as well, we got some positive feedback in terms of people's use of it, so how they identified bottlenecks, how they identified performance issues quickly with the tool as well. So I'd like to now jump across and do a quick demonstration. I think we're okay in terms of time-wise, so hopefully this will give us a flavor in terms of how would one use it to troubleshoot and triage some issues in your cloud or virtualization environment. So hopefully you can see the screen there in terms of an instance of VPV. So I wanted to do a quick orientation tour first to give you an idea of how it's laid out. So across the top, you'll see the hierarchical breakdown in terms of what we have in connected to VPV. So In this circumstances, we're connected into VMware. So we've got one data center made up of 2 clusters, 2 ESX boxes, 3 resource pools, and a total of 15 VMs with indication of our data stores and where our VMs are stored and the latency. So you'll see within those tabs, as I click across, the tree view will change down below. So you have the concept of looking at CPU usage in this particular one at the data center layer, the memory usage by clicking across, and the VMs online, etc. And the boxes if you hover over the box, you'll see, well, it's based on the number of guests and the offline, the percentage of offline VMs, and you get a description of what that tree view map is, or tree map view represent down in the bottom right-hand corner there. You've also got the concept of these micrographs which get updated in near real time, so it gives you an indication of what's happening quickly on the box. And then as you go down through those different tabs, you get into a stage where you're down at, in this circumstance, it's down at the virtual guests layer. So you can see here the boxes represent the size or the available CPUs in this circumstance, in this situation allocated to it, and the usage of same. Okay. So the bigger the box, the more resources allocated. The color denotes then the utilization of that resource, whether that be memory or CPU, etc. Across the top then, we'll go to these shortly in the demonstration, but this is where we're getting access to that workbench, so the drill down, more deeper information, our capacity and usage trends, find a VM placement. So where can I place a VM of a certain size of resources? Where does the system say is the best place to place that VM, or the best cluster or resource to place that VM? And then the area of forecast. So anything that's there can be exported to a PDF in terms of reporting. Here we have the admin panel to go in and first of all, the first thing you got to do is connect it to your hypervisor or cloud layer, give it the credentials, let it log on, and let it gather the information. And then you have the usual troubleshooting tips and help. So down on the right-hand panel here, you can see that we're obviously working on a vSphere domain here, but you have the possibility of switching to the other platform that you have configured VPV for, to see it by that. We have the possibility of group by, so whether we want to group those VM by data center, cluster, resource pool, etc. Here's a quick and easy way of sliding back the time to see what's happening over a period of time, and then it's summarized in 5 minutes. This denotes then how we're using the color within those boxes. So is it CPU usage, memory usage, ready CPU, that type of thing. And we can then use this slider here to filter out where, so in this circumstance it's not a big issue because we don't have a huge amount of guests within the system. But for example, if you had a large amount of guests, being able to filter out and see only the ones that I'm interested in terms of the ones that are having problems. So that ability to do that. And on the bottom then you have a quick view in terms of the top VMs that are using, you know, are having issues in terms of performance and the utilization of the resources they're given, or the bottom by switching between the two. And then again, you've got those micrographs updated in near real time. So let's take this situation where we've got, you know, there are some VMs struggling in terms of high usage in terms of CPUs. So a virtualization expert could individually look at those systems, but more interested maybe in seeing, well, is there a pattern? What is there a problem in terms of maybe why is it a coincidence that all these systems are having a problem, or is there something more underlying that's causing the problem in the first place? So this is where the group by could come in. So for example, I might want to group those by resource pool and say, no, well, it seems to be occurring in the 3 resource pools I have at the moment, so that's not the problem. I may want to look at, say, the CPU ready. So, you know, is there systems that are looking for CPU resources and not getting them? Again, yes, there's problems happen there. I can highlight those particular ones and say, okay, well, they're the ones I'm more interested in. So why not look at those in terms of resource pools? Again, across two different resource pools, so that's not a pattern. You may want to look at it then in terms of cluster. Is it related to a cluster? So there seems to be a pattern here in terms of demo cluster 1. All those particular VMs seem to be related to demo cluster 1. So we've seen some sort of a pattern. We're able to quickly, through a few mouse clicks, find out, you know, where that problem might arise. I can then group those. And now I'm able to launch into the workbench. This is, as I said earlier on, the ability to get those visual insights into the metrics that we're gathering for those particular VMs. So anybody familiar with our performance management tool set will see similarities here. So here we have on the left-hand side, we have that grouping of virtual systems. So let's choose all those systems. And here we have in the center pane, we have the metrics available to us so we can start triaging what the problem is. So whether they be CPU, disk, memory, and network. So since we're talking about CPU issues, it's a case of taking that metric and dragging it across to create that graph so we can start triaging. So here we're seeing those VMs and the CPU ready time. So then we can start bringing across other metrics, etc. So giving us that quick access to that system. So in the CPU ready time, it looks like maybe this particular one is causing, it seems to have the biggest problem, so VM14A. Verify that by switching on and off in the graph. We've also got the concept of a timeline as well. So we could take, let me get rid of a few of these graphs. We could take one particular metric, drag it up onto the timeline, and then move that cursor back and forth, and all our graphs then will move in accordance to in the context of that particular metric. So again, being able to switch back in time and see, well, when did the problem started happening? What else was happening? Do I need to start dragging across, you know, other metrics in terms of network, memory, disk, etc. And here then we can start looking at the time range. So that particular VM seems to be have issues. Again, we can start bringing across individual metrics for that particular one and start homing in on where the problem is arising. So superimpose them or separate graphs, etc. So we've seen that that particular VM, lab VM14A, seems to have issues. So why not drill down into the actual guest itself, so using the OS drill down. So again, from one tool, we're now down into a troublesome VM, and we're looking inside the VM as such at this stage. So usual suspects in terms of CPU, memory swap, network, etc., all updated up to 1 second time frames. And you have what's called the process cloud down here. So what's running on that box, what processes are running on that box, and which processes are taking up the most amount of resources. So the representation of the name, the bigger the resources is taken up. So funny enough, it's called heavy load in this particular demo environment. So clicking on each one of those will give you more information in terms of, you know, the the metrics and information about that particular process. And you can click across in terms of the tab here to get the type of information one would need to be able to work out what the problem is in the first place, whether that be file system, space utilization, space used, is it a storage problem, network problem, etc., and what applications are running on that system. But the Process Cloud is being able to give us some sort of information in terms of, you know, what's happening on that box. So they may be the owner of this particular process or application or whatever that needs to be contacted, etc. So that's the triaging. Oops, wrong X. Sorry about that. I wanted to quickly now go through some of the other aspects of the capacity management. So we talked earlier on about capacity usage trends. So here we're seeing the gathered information over a period of time for our data centers, clusters, hosts, and data stores. So here we're seeing an indication of the systems that have been undersized, right-sized, and oversized. So, you know, there's compute power that we can retrieve and allocate elsewhere if necessary. And that's in terms of CPU, memory, etc. And what systems are idle, what systems are more active all the time. And then you can drill down into, you know, more detail in terms of at a data center layer, or in our case cluster layer. So we have two clusters. So here we can see demo cluster 1. We've got a total of probably 21 gigahertz that we can reclaim there, and 15 gigabytes based on resource usage on that box. So drilling down into the actual host itself, we're getting deeper in terms of the information we're getting. We can then look at, well, okay, it's telling me at 21 reclaimable gigahertz there, where are those 21 reclaimable gigahertz allocated to? So here we have the VMs that are hosted on that, which ones are oversized, which ones are undersized, the current CPU, and the recommended CPU based on historical performance. And in the interest of time, if I quickly go through some of the other aspects as well, find VM placement, a useful utility. So I've got my virtualization layer and my cloud layer. I want to see, well, where can I place a new machine? So give it the number of virtual machines you want to look for resources for, CPUs, memory, disks, add them in, and then find where I can place those. So it's giving me a recommendation that I want to place it on demo cluster 2. Then go into the trending aspects of the product. So here we've been gathering this information over a period of time, and based on the performance issues that we've encountered, where am I going to be in 30 days, 60 days, 90 days time? So giving us that trending ability to be able to say, well, okay, I'm okay for the moment, but at some stage I'm going to need to increase resources on that box. The days to capacity is obviously greater than 90 at the moment, so there's no major issue. But should you be running out of resources, it's going to give us an indication of where that problem is going to arise. So that was a whirlwind tour of VPV. Just to sum up, we've seen ability to quickly ascertain where a pattern may be, drill down into performance metrics to triage that problem, go further into a specific VM and get details in terms of what's happening on that VM. We've looked at the capacity usage and the trending ability and the easy use, I think, of VPV. So hopefully that's given you a flavor of what it can do in your environment. just to, I suppose, try before you buy. So it's there to download. As I said, there's a community version that you can get up and running fairly quickly, or there's an evaluation 60-day that gives you all the functionality. And I think you'll see that, you know, in less than 30 minutes you're starting to get information into the system. Obviously for trending and forecasting it's going to need a little bit more time, but that once you have it up and running, it's gathering that information for you. So I'll thank you for your time, and I'll hand back to Amy.
Okay, but thank you so much, John, and thank you everyone for joining us on this webinar.